Hello everyone, how are you all? Welcome back to the channel again. I hope all are you good and learn something new with day by day. And I hope whatever information or you can say whatever I taught you in these videos, right, a practical or a theory basis, it will help you in your learning journey on your table, right? So today we have a new case, a study case, right? This is a Vivo, right? A Vivo phone, right? So it's in a dead condition, and someone already work on it, right? Like these shield, because most probably the phones comes from me, right? A dealer's phones, right? From the another shop. So first they will try it. So someone already work on it. Right now it's in a dead condition, and now we diagnose this phone. Right now, let me try to on, and it's not boot. Right, nothing, no symptom. Right now, when we check the battery, right, measure the battery voltage on it. The multimeter on it. Now the multimeter on DC voltage mode. Okay, so let's we check it. The battery voltage. Right, a battery voltage is 3.7. Maybe connectivity issue. So battery almost charged, right, but it's not turned on. Now let me check the diode value, right? So now we diagnose this phone, right? And let's see we repair this phone or not, right? So watch this video. Now we check on a diode mode, right, on a reverse bias. Now this is a ground, and this one is a positive 343 diode value, reverse bias. Now in a forward bias, it's 1000 plus. It's okay according to the multimeter. It's okay, right? Now we check on a VPH V system line, right? A similar how much diode value or VPH. So this is the power IC and the buck inductor. In between there are some capacitors, 7 to 8 capacitors which connected to VPH line. So we check on VPH lines, right? So let's check it. 363, right? It's okay. And under the microscope, let's see for more clarity. So this is our power IC, right? These are buck inductors, right? In between these are caps, small components, VPH capacitors. So 362 on VPH line on a reverse bias, okay. On this one, no connectivity. Let me check again. 363, it's okay. The VPH is okay on reverse bias. Let me check on a forward bias. 963, 964, right? It's around about 1000. It's okay, approximately. Now look at this. Someone work on this phone already. How to remove shield? I mean to say how the shield remove someone. Even the second layer is visible, right? So this is not the good way, right? Now look this. Look here. This is someone peel properly to the cutter. So this is not the good thing. Always work with perfection, cleanness, right? So if someone work like this is not the good way. It's damage your reputation. Now look at this. There flux here. So it's not a good way to work, right? Now check the other side of the motherboard. Any work, right? Let me show you. So no work on other side. Let me show you in a main camera. So look at this, there is a no work on other side, only work on that side, right, near the power IC. Right now VPH is okay and VBAT is also okay according to the multimeter in a diode mode. Right now we connect in a charger and let me see the how much consumption. Right after we check on a DC power supply. Right, so let's pack the phone and connect with the charger. Right, a charger meter on a top side. Right now I am connecting a charger. Wait a second. Now focus on a charging ampere meter. Now I'm connecting a charger. Now focus in. Just is charging ampere in and take and drop. When I connect the charger, focus on the ampere meter. It's ampere taking ampere after drop. Look at again. It's taking ampere and after suddenly it's drop within a second. Right now we check on a DC. Disconnect the battery. Right on a charging, when we connect a charger, it's taking some ampere and after suddenly drop. Now I'm set the DC on a screen. Wait a second. Now DC on your front of your screen. Now we connect our DC power supply to the battery connector. Right, so this is our ground point and this one is a positive. Now look at this, it's take auto ampere. I am connecting again, I will show you. Right, when I connected it's taking 0.9. Right, my DC machine is 5 digit. I am tell you according to the 4 digit because mostly technician has a 4 digit, so it's taking 0.8 milliamp according to the 4 digit. Right, does not count the last digit. So this is a minor shorting or you can say leakage. Right now we try to turn on. Right, wait a second, it's a auto consumption. Okay, now we try to turn on. Now I'm press the button and look at the graph. Its movement, I mean to say a graph changes. Right, when I press the button graph changes and that means something, maybe it does not connectivity or lose something. Just a second, something not properly. Right, the graph has changed, something get wrong. So I'm disconnecting and I'm connecting again. Look at this, it's taking 0.9 auto consumption. Now I'm pressing the button, on off button, and after we see the graph. Now it's taking ampere 146. Right, 27 61 milliamp, 27 61, 27 61. Right, around the 100 milliamp sometime, 145. Right, so it's now look at the graph, it's in a variation, in a fluctuation. I'm releasing the power on off button and it's taking between 10 milliamp to 100 milliamp, approximately 146. Right, so in between this is in a fluctuation. Right, so it's not properly boot up. Right, it's a auto consumption first, secondly it's not properly boot up. Now we check on a VPH. Right, let me check on under the microscope so it will clear to you. Now these caps, right, small caps, we check here. Right, now this is the power IC. Right, now let me DC power supply set, and because there is a auto consumption on VBAT, so we inject voltage on VPH. If there is also a shorting on VPH. Right, look at the DC power supply carefully. I am setting it. Now in a bigger way, now black probe on a ground, and with the red I'm injecting on a VPH, right? Let's, now I'm connecting. Now look at this, 13 milliamp, right? Auto consumption, right? 13 milliamp. Now on a VBAT 0.9 milliamp. Now here is the 13 milliamp according to the 4 digit. So there is a also a short in VPH. It's also a minor. You can't find it with even a thermal cam. This kind of the shorting, right? Now look at this on this capacitor, 13 milliamp. So it's a minor shorting, clearly, right? Now we check on a voltages, right? On a VPH, VBAT, how much of voltage on this line, these lines, right? Multimeter on a voltage mode. Wait a second. No, on a main camera. Let's move on to the main camera. Now under the main camera, right, we measure a voltages on VBAT, also the VPH. Now I'm connecting a charger. Look at the charging ampere meter. Now charging starts and battery disconnected. Now we check on VBAT. It's 2.1, 2.2, right? Now on a VPH, let's see VPH is generate or not. VPH also 2.2 voltage, right? 2.1. In normal cases we get minimum 3 volt. Now under the microscope, right, let me check again on VPH on these capacitors, right? Now look at this, 2.1, 2.2, approximately 2 voltage. So in a normal phone VPH get 3.7 to 4 volt, minimum to minimum it's a 3 volt, but right, in this phone we get a 2.1 voltage or 2.2. Similar voltage we get on a VBAT, on a battery connector. Now let's check the IC number, which IC used as a power IC, PMU, clean. Now it's look at this, PM439. Now as clearly this phone had a minor shorting. Now let's check the buck voltages. Charging connected already. The buck has no voltage on this one, and this one has also no voltage. So what's happened? The VPH does not generate the buck voltages. Why? Because power IC input requirement is VPH or V system, but the input requirement is not fulfilled properly. The requirement is here, but it is a less, right? There is a shorting, so the power drops, the consumption, right? So power IC does not enable, I mean to say active, right? Look at this, a 2.1, a 2.2, right? Now look at the buck, no buck voltage, because the power IC does not produce the buck voltages. Look at this, because the power IC does not activate. The requirement is not fulfilled. If the power IC requirement is fulfilled, then the power IC produce the voltages, right? Now let me Now on a VBAT 2.2, 2.1, a similar voltage as like a VPH, like this. Similar. Look at it. 2.1, 2.2. Right? Similar on both lines. Right? Now I will explain you something so you can understand a better way. Wait a second. So let's suppose this is our power IC, right? PM, PMU, right? PM, power IC. Power IC generate the buck voltages, right? All some LDOs, right? Now these are buck lines, right? Let's suppose, right? Now this is our CPU, our main processor master, right? Now buck lines connected to the CPU for fulfill requirement to the CPU and some LDOs also, right? Now this is a power IC as output, the buck lines and the LDOs, right? For producing or generate the output, power IC need some internally input, right? Requirement. The requirement is a VPH, right? It's come to the many ways like a VPH, right? Ready? How many buck lines you will see the VPH is right on these capacitors internally, right? So these caps had a VPH. VPH got multiple ways. Now VPH comes from another IC, right? It's from PMI. This one we call charging IC, a BQ IC, right? A DC to DC. Now VPH comes from this IC, right? So this is the basic structure, right? Now this is input of the power IC and output of the PMI, right? Now PMI IC also had requirement from V bus, mainly a charging connector, also the VBAT we call a battery, right? Battery voltage. So that's the PMI generate the VPH. This is the basic structure. Now in this case we get a leakage on output on a VPH, right? Also in a VBAT, right? Now there is a leakage. Now what happened here? Now we get a 2.1 voltage on VPH, right? No, but we need minimum a 3 volt. In a normal we get 3.7 to 4 volt, but a minimum we need a 3 volt, right? Now but we get only a 2.1 voltage on a power IC. So power IC does not produce a buck lines, and the buck lines does not produce and the CPU does not activate, and your phone does not turn on. This is the simple circuit. Now there is a leakage first. Now the VPH is also the PMI. VPH produced by the PMI, right? So we check a VPH, I mean to say PMI, if there is a fault or not, right? Because the VPH produced by the charging IC, so we check the PMI first, right? So we remove, I mean to say open the motherboard. So let's test on a charging IC. On the other side, on the under this shield there is a PMI, right? We remove this shield. So So this is our PMI IC. Now we check our VPH here on the VPH coil, multimeter on a diode mode. So VPH 327, now in a forward bias. It's around about 950, 960, right? So approximately 1000. So it will be work, right? According to the multimeter. Now let me check the voltages on the VPH, right? Actually, we get a main cam under the main camera. Now let's pack it and connect a charger. So we check the VPH voltages. Now we check here on a VPH coil how much voltage, right? Now we measure the voltages, connect a charger, right? Wait a second, just a second. Now we connect a charger, right? Look at the charger connected, ampere starts, right? Just a second, again disconnected, right here. Now right now it's working. Our charging ampere meter is working now. Sometimes it's difficult to handle multiple equipment in a one screen, right? Multimeter on, now multimeter stuck. Wait a second, I will resolve this issue also. Right now in diode mode. Okay. Now we measure the voltage on a VPH coil, right, under the microscope. Just 1 point, just a second, 2.1, 2.0, 2.1, right? A similar, just a second, just right. Now let me check the boot cap, 1.68. Let me check on 1.2.1, maybe connectivity issue. Just a second. This side 1.8, 1.9, 2.1, right? So this is the VPH side, and this one is the IC side, but there is a other side connected to the IC but no boost. Now this one is a V bus connectivity input, and this cap, this phone had no schematics, right? So this is the input, this is the VPH is also drop, right? So this is the boot cap. On the other side a similar voltage, right? No switching here, right? A 2 point, a similar. Now this phone ad is a no schematics, right? So we work now. We change this IC because I think this IC has a faulty, because the switching problem, there is some MOSFET, so it's not working properly, any leakage under the IC, right? So one time we replace the IC, let's see it's work or not, right? So we replace this IC, right, are charging IC, because the boot cap had a similar voltage on both sides. Also the VPH drop, right. Now first clean this properly. Okay, now let's remove this IC and replace with the new one, right. A little flux here, right. And my heat is 350. Now we clean this IC. Now we replace with the another IC here, right. If the problem is sorted out or not, let's see. Now this is a new IC, oh, right, and this one is the old IC, right. So we replace with the new IC. Take aside this IC and we reball it first, because this IC is used, right, recover from the scrap boards. So we reball it. Now we place this IC. Now the flux is out, and just little move the IC. So now the IC is fixed, right? In between the board is cooled down. I will explain you something, right? Now while the phone is cooled down, and we test the phone if it is okay or not, I will explain you something about the repairing, right? Before repair any phone, I mean to say conclusion or decide there is a fault, you diagnose properly, right? Each and everything, each and every line, right? If you check one or two lines, let's say, right, one or two lines, and depending on a one tool, like multimeter or DC, only uses one tool, and you will decide there is a fault, this line had a fault, right? And this conclusion will be most of the time wrong. Now for example, look at this case, right? When we measure on a VPAT, diode value is okay, right? On VPH is almost okay, right? When we check on a DC power supply, right, it's take auto consumption 0.09 on VPAT. On VPH it's take 0.013, right? I am talking about, right, a 4-digit, because most of the technician had a 4-digit power supply. That's why does not count the last digit, so it's a 13, right? So shorting in VPH, right, it's confirmed. Now if you run only behind this logic, there is a short, right? There is a less chance you will be repair this phone. Why? Now we change the IC, but there is other reasons also, right? Now if you're looking only the auto consumption, right, there is a shorting, right? Now let's say first you apply a Rosen method, right? Now VPH is connected almost every section, right? So when you inject, let's say 4 volt or 5 amp, right, on VPH, let's say, there is a less chance you will be find the short, because in this consumption or less consumption, there is a minor chances any component or any IC will be heat, right? If you find through a thermal, mostly people does not have a thermal camera, but if you had, then also there is a 90% chance this consumption does not find by the thermal camera, only a 10% chance a premium thermal, right? But 90% does not find the shorting, because there is a less consumption. If the consumption is high, then you will find with the, depending on the consumption, right, with the Rosen method, also with the thermal cam. But in this consumption there is a less chance, right? Now some people says, when we measure VPH after connecting the voltage, the VPH generate 2.1 voltage. So minimum volt, let's say 3 volt to 4 volt, but there is a 2.1 volt. So VPH generated by the PMI, your charging IC, right? So that's why we work on a charging IC. It's okay, but let's say VPH connected to the power IC, PM, it's also connected to the other sections like network, graphic, LCD, audio, Wi-Fi, Bluetooth, many sections, right? Now let's suppose in a audio section, a component called capacitor in a leakage, not in properly short, it's only a leakage or IC leakage, you will see a similar situation, a similar current consumption, because this is also connecting on a VPH, right? Now there is another question, if the IC also generate the VPH, right? If there is a short here, the voltage drop also here, right? So that time you will be confused. Now if you had a knowledge, you will see other things also. What are the things? Let's say from the starting, right? Diode value is okay, right? So we did not work on it, diode value according. Now when we connect a charger on a with battery, you will see a current consumption, a little current consumption, suddenly it's drop on a next second. But when we measure on a VPH voltage, you will see the current consumption without battery. Also there is a 2.1 voltage, right? Clear? Now when we inject, I mean to say check with the DC power supply, right, on a battery connector, and I am pressing the switch, the reading is like, say, before pressing the switch it's 0.09, right? After the pressing the button it goes to the 27, 45, 61, 100, 145 milliamp, approximately 100, let's say. After that, releasing the button, the consumption will variate in these voltages, 10 milliamp to 100 milliamp. Now according to the theory, let's say after the 30 and the 40, right, the power IC PM will be boot. After 70, depending on the phones, 60 to 70, your CPU will be boot. Also you will notice that when we check connecting with the charger, right, there is a 2.1 voltage, clear, but buck has no voltage on the buck lines. Clear? Got it? But when we inject the voltage with the DC power supply to try to turn on this phone, right, it's taking 100 milliamp, let's say, consumption, right? According to the theory, the power is on, also the CPU on. For the CPU boot up, the buck requirements need. That means the buck is also had a voltage, right? That was the clue, right? That means the power is okay, the CPU is okay. For the shorting reason, we work on before the power. Clear? This is another clue, right? Now how the charging IC work? First of all, you will understood easily. That's why I am always tell you the basics are important. The power IC had two inputs. I mean to say two requirements, two power source requirements. One for the V bus from the charging point, other from the battery, right? Now when you connect the charger, your phone on a charging mode, let's say work on a charger, right? So this is a PMID cap. Everybody know the rule about the PMID. Let's say this is our boot cap connected to the IC, and in this line there is a coil, and after that this line goes to the VPH, and same line goes back to the IC, right? Clear? Everybody know the charging circuit? Similar. After that, the another line, this line, right, internally this line out and goes to the battery to charge the battery. Clear? So what happened? This IC had multiple MOSFETs, right? So one of the MOSFET, right here, right, are leakage. Charging IC does not short properly, internally leakage. So your charging work depending on the charging section does not work properly. That's why when you measure on a VBAT voltage, it's 2.1, similar voltage you will get a 2.1 because this line had came out. But when we inject the DC power supply, DC power supply had a 4 volt, so 4 volt goes to this line, and through this line it's directly bypass this and goes to the VPH. That's how your power IC had a proper voltage, right? A input, a VPH. That's why the power IC generate the buck voltages, and after the buck your CPU turn on, right? But there is a leakage on this IC on a VPH, so that's why this leakage drop the current and the phone does not turn on. Clear? I hope you get my point. After we decide check this IC, and in a boot cap there is a no switching, the final. That's why we change this IC. So what I'm telling you, before go to the any conclusion, right? Let's work on the other things. If you focus only on this thing, and you will ask someone, let's say there is a short, if you do not count other things, testing other things, you will be struggle a lot. There are multiple things you can focus as a technician, as a experienced technician, right? Your first job you had a good knowledge. Also as a technician, sometimes you will think out of the box. You know the theory is good, knowledge is good, but according to the experience, sometimes you will think out of the box. The question why, every time I will say to you, if you know the why, then you will repair and confident why there is a fault, and why the fault comes and how to solve. Otherwise it's a fluke if you solve the phone, right? Let's say by chance you repair, I mean to say remove the charging IC and suddenly it's on. It's a fluke. You does not know anything. But if you know the circuit, you can confidently say there is the fault, and there are multiple reasons that I will show you why. Now let's go to the phone and wash it, and let's check the turn on or not. Now clean the board properly, and with the always work proper cleaning, I mean so cleanliness, right? So the IC is proper fixing, right? So okay, also with the proper cleanness, always work with the cleanness, right? Now we test again under the microscope. Just a second. Right, now we test here, right? First a volt, let's say diode mode first, right, on a multimeter. Just a second. Now multimeter on 356 on a reverse bias. Now let's check on a forward bias. In a forward bias it's 1368. Before it's 957, Now it's 1000 plus 368, right? Now it's okay. 1000 plus, right? Right, before it's a approximately 1956. Now it's 1000 plus. Now we connect a charger and let's see the voltage mode. Now charger connected. Look at the charging ampere meter. Battery disconnected. Now we measure the VPH on a buck line. Is this VPH coil? Look at here, 3.1. The VPH is okay, right? Before it's 2.1. Now let's check the boot cap also. 3.1 on a VPH side. Now let's check the other side. 7 voltage, right? Just a second, connectivity issue. Just not connected properly. Let's take a help for the blade. Right. Just a second. Uh, 8 voltage, 9 voltage, right, on this side, right? Let me check again. This side at 8 voltage, right, 9 voltage, and this side had 3.1 voltage. Maybe connectivity issue will just let me check again, right? Approximately 3 voltage. Let's 3 voltage, 3.2, 3.4, 3 plus, and this one is 8 voltage. So right, 4.3, right? It's okay. Now VPH is now okay. The IC switching properly. So let me check the VPH here. It's 3.1. It's okay. Now let's try to on, right? The voltage is complete. Now let's try to fix any changes on phone. Let's try to turn on. Now the phone turning on, right? Right, before it does not turn on, as similar, right? The fault in between the charging IC does not work properly. It's internally a leakage, right? That's why our VPH is dropped, right? Now wait for the turn on properly. This IC has internally half short, or it means a leakage, right? This IC is a leakage. This one is our charging IC. And why we diagnose, I mean to say remove this IC, I will explain you everything. First, the phone turn on, right? Now I will tell you how to diagnose step by step. Now phone turn on, right, but the screen does not visible properly. Let me check. Now the screen is visible. Maybe a brightness low, right? Let me see the brightness. The screen is visible. Let me check. Right, the screen is visible, keypad is working, right? Maybe the battery saver on, right? So that's why the brightness is low, right? But the brightness, right, the customer had a pattern, so we, right? So this IC, the power IC, is completely okay. As I told you, the fault comes from anywhere, but in this case the fault is a charging IC. So we remove and check why the charging IC leakage. I will also tell you. Now let me turn again the vibrate phone, and the phone turn on, screen visible. So let me connect a charger, focus the charging. Let's just take 1.8 ampere, right? Let me disconnect again and connect again, and 0.6 and 1.8, even a fast charging enable, right? Now wait to turn on again, right? Just a second. Now for the phone turn on completely. Okay, now, all right. So if you learn from this video, like this and subscribe this channel. Thank you so much. We will meet you in the next video, right?